Alright, hello everybody, and today we're going to be taking a look at something a little bit different. We're going to be doing some CAS programming, and in particular some CAS programming for probability. So I have right here a program that I've written called Binomial Info, and if we run this program right here, we're going to be asked for two things pretty much. We're going to be asked for our n value, which is 4, our p value, and we'll just set that as 0.3 for now, and we're going to be asked if we want to generate a probability table, and we'll just put a 1 there, just to say yes, and it's going to do all of this work for us. So here, what has it done? It's given us information on the expected value or the mean. We have the variance and the standard deviation all laid out in a nice matrix, and not only that, we also get this nice table right here which tells us the probability of getting each of these values right here. So this is quite a nice program to have actually, because you just get so much information from entering in two numbers. So we're going to be taking a look at how we can program this today. So we're going to be starting from scratch. So let's open up a new document. So new document like so. I'm going to add a calculator page, and we're going to go ahead and go to menu, go to functions and programs, program editor, and we're going to open up a new program, and let's name this program something. Let's call it exactly what it was in the other document, binomial info, and later we might as well chuck this in the public library, so we might as well set the library access to libpub like so, and click OK, and we can hold Control and press 6 to split the page, and Control arrow key to the right to access this programming page right here. So what exactly do we want to recreate? Well, first of all, let's focus on how we can get these inputs right here. So the program is pretty much going to ask the user to input two values, n and p. We might not include this step right here, because we'll just set it to 1 automatically. But yeah, let's just focus on getting those two inputs in. So to get those, all we need to type in the program is just request, like so, and I'm going to put quotation marks, and inside these quotation marks we're going to put whatever we want to show in the dialog box. So as you can see, when I run this program, we have an n equals thing in the dialog box right here, and that's exactly what we're going to put in the quotation marks. So let's put an n equals, and I guess just to make things a little bit more clear, we can clarify this as the number of trials, like so. You can do something like that if you want, and we can store this as a variable, so we have to put a comma and then n like so. And we can do the same thing for the p value. So when we run this, we get the n value and the p value as well. So pretty much the exact same thing. We're going to request space and quotation marks, and we can put in probability of success like so, and we can put a p equals if we want to, and then store that as a variable. And we can run this program as it is right now. It's not going to do much, but if we press Control D and we go back to our calculator page, and we can click on the var button right here, we can just do Control L and click on this program, run the program, and it's pretty much gonna do the same thing as we saw in the other document. It's gonna ask for us for the n value, so we'll just put 4, and the probability of success will just do 0.3 for example. And notice that if we go to our var again, we have our n and our p stored as variables, and you can choose to have that if you want or not. I personally choose to have that, to have those variables floating around in my document, just in case a question comes up and it asks me to compute something that involves the n value or the p value. I have everything ready there for me to use. So back to the programming page. What else do we want to do right now? As you saw before in this other page right here, we have the expected value to find, we have the variance to find, and we have the standard deviation. So we might as well define those things right here in the program based off what we have with the n in our p-value. So to do that, we can just simply define, and to define our mean, you can go to this little symbols thing right here by pressing Control whatever this button is, the catalog button, and you can go down to your mu if you want to, so the Greek letter mu. But just to keep things simple, I just like to use the letter u. It looks almost the same as mu. So we can define mu as being the mean of this distribution. So the mean of a binomial probability distribution is just this n value times the p value. So we can define mu as being n times p, like so. And similarly with our standard deviation, usually it's denoted by sigma, but we'll just use O in this case. So we can define O as being the standard deviation of this distribution. But the thing is, we know that the variance, so the variance of this thing is equal to n times p times 1 minus p, like so. And the standard deviation is just the square root of the variance. So we can define O as being the square root of this exact same thing right here. So that's going to give us the standard deviation. That should be right. So what did I miss out? Oh, we need a multiplication right here. There we go. So we've defined our mean and we've defined our standard deviation. And let's actually just work on getting this table right here, the expected value, the variance, and standard deviation, since we've already defined everything. So back in our programs page, let's just go down a few lines just so we have more room up here later on. And what we're going to be doing is we're going to be inserting a matrix, and we specifically want a 2 by 3 matrix. So to do that, I'll just go back to my calculator page, and I'll just go to where is it, matrix and vector, and we're going to create a new matrix. And so we want the number of rows to be, or is it 2, and the number of columns to be 3. Click enter, and we have a matrix, and we can just copy paste this, cut paste this into our program. So we want to display a matrix later on with all of these goodies inside. So to display information in our program, we just simply type in disp, like so, and we can check our matrix right in right there. So we're going to display a matrix later on, and we're going to fill all of this stuff with something. So let's see, we want the expected value, variance, and standard deviation, just like we have in this program right here. So to get those displays working, what I like to do is I just like to put in quotation marks and type in E, square brackets, X, and X right here is our random variable. The reason why I use quotations, I'm pretty sure if you just type it directly in, like so, yeah, you get these weird things where it treats all these symbols like math symbols, and yeah, it won't really display too well in the actual output. So that's why I use quotations, like so, because everything inside it just treats it like a string. So we have the expected value. What else do we want? We want the variance, so let's just type in var square bracket X, like so, and we want the standard deviation, so we'll do SD and X. Alright, cool. And remember, we've already defined all these mean and standard deviation things right here, so we can just pop those right into these entries right here. So our expected value was U, and our variance is, well, just the square of the standard deviation, so we can just do O squared, and standard deviation, well, just this sigma right here. And the output of the program won't actually display these letters right here. It's actually going to display the value of whatever these variables will be. So if we hit Control B to save the program, and we go back here, and then we run the program, it's still going to ask us for the number of trials, so 4. Probability of success, which is 0.3, so we'll enter that in, and now as you can see, we have this nice matrix right here that gives us all the information that we want. So yeah, I'll just demonstrate what I was talking about earlier with the quotations. If you don't have the quotations, then you just simply type in e square bracket x or something like that, it's just gonna turn like into lowercase because it's treating all this stuff like math characters or math symbols. And if you run the program, yeah, it just doesn't look nice. So yeah, that's why you want to use quotation. So var of x right there again. Alright, cool. Control B to save. And you see in the original program, I've included this expression right here where it states that x is a binomial probability distribution. This is useful because you might not know exactly what this x in this matrix thing is. So it's good to specify what exactly x is. So if we just go to the line before, so on top of this matrix, we can display that exact same thing. So we can display x. Actually, do I need to use quotations? Yeah, I think so. So we can just display x is this squiggly symbol right here. Basically means is some kind of distribution, and we have bi for binomial. And right here, this is a bit of a tricky thing to do because we want to somehow in this expression right here use the numbers that we've input into our program. So we want to somehow let's just get rid of all this junk right here, we don't need it. We want to somehow use this n value and this p value in this line, and we can't simply put it inside of these what do you call them, these quotations right here, because it's just going to treat them like a string, and we want to treat them like variables. So we're going to do by, like so, bracket, and the layout or the format is just n comma p. And to achieve that, what we need to do is we're going to exit this string right here, and we're going to put a comma, and I'm going to display a variable. So we're going to do n, and to get the comma, we can't just do another comma like that because this is kind of treating it like a math operation at the moment. To get the comma right here to display, we need to go back into, I guess, displaying the string. So we need another set of quotations right here. We're going to put a comma in like so, and that's going to ensure that the comma will be displayed. And now to get our p-value, we need to get out of this quotations right here because we want to display variables, not just text. So to get out, we're going to make sure we put another comma in to kind of separate it. And then now we can put in our p-value like so. And we kind of want this bracket right here to show up just to make things look nice. So we need to display the bracket, so we need to put a comma and then quotations right like so to get back into entering text, and then we can close it off with parentheses like so. And this should work. If we hit Control B, we shouldn't get any errors because we should have all the commas in the right space. So yeah, this is a bit of a tricky step to do because we have to display some text right here, and then we have to switch to a variable. So to switch between text and variable, we always have to include this comma right here, and then a comma to go back to displaying some text, which is a comma right here. And then to transition to displaying variables, we have to put more commas everywhere, like so. Alright, so if we go back to our calculator page and we run the program again, notice that this thing displays nicely, just like it did right here. And just a nice thing to take note of, since we defined the n and our p value, as well as our sigma and our mu globally, what actually happens is if we run the program, the n value is already stored, so it just displays like that for us. We don't need to actually put it in for the next rounds. And this is particularly useful if you're going to write a program for example, binomial CDF. So I'll just demonstrate this in this document right here. We have binomial info, and we can run the program like so, generate probability table. And then I'll also have another program right here called binomial CDF. And if we run this thing right here, notice that all the variables are stored because n and p are global variables. So that's a nice thing, just to save some time, and we can go ahead and add lower and upper bounds if we want. And yeah, that program does the calculation for us. So yeah, I guess it's a nice thing to have our n and our p, sigma and mu and everything stored globally, so we can access them whenever we want to. And of course they do update as you use the programs. So going back over here, we've basically got this whole section right here figured out. So with this display right here, this expression, as well as this table of this information table with the expected value, variance, standard deviation, and so on. And now for the tricky part, which is trying to get this table of values right here. And this thing right here is really quite tricky to do if you're just starting out, because it's dependent actually on these variables. So the size of the matrix is dependent on this n value right here. So in order to do this, let's just jump back into the programming page. So this section right here is already done, so let's just move that all the way to the bottom, get that out of the way. So in order to get started right here, what exactly do we want our program to do? We want to display all the probabilities as well as all the x values. And in order to get everything inside of one nice matrix, so everything looks nice and uniform, I guess, we have to define each of these lists right here separately. So let's define the first list as being just the list of these x values right here, and this is quite easy to do, I guess. We're going to be using something called the sequence function or command, or whatever it's called. It's just simply seq like so. And basically what this command is going to do for us is it's going to generate a list. So the syntax is as follows. We have some expression, and then we have the variable, and then we have where it starts and where it ends pretty much. So for this first list right here, this list of x values that goes from 0 all the way up to 4, or this n value, what do we need inside of this sec commands right here? Well, let's just choose some kind of dummy variable. Let's just call it k. So this is what we're going to be kind of seeing, I guess, this k, and our variable is k, of course, and we want this k to count from 0 all the way up to whatever our n value is. And if we actually display this output right here, if we just display that and run our program, notice that we get this nice list right here that goes from 0 all the way up to 4. And in this program right here, we have it inside of a matrix. So later we're going to be defining a list of things right here, and we're going to be defining another list, and we want to combine all of this stuff inside of one big matrix. So it would be nice if we can convert this thing right here into a matrix, because at the moment it's just a list. So this list right here, in order to convert it to a matrix, we can go to our catalog and make sure you're on this one right here to get all the functions and programs and whatnot. And we're just going to hit L, and we're going to scroll down until we see list and map like so. So this will convert a list to a matrix. So if we chuck that in and make sure this sec commands right here is inside of these parentheses like so, this is going to turn this list right here into a matrix. So if we save this program and we run it again, notice that instead of having a list, now we have a nice matrix, which is really nice. So we have this part figured out, and now let's go back to the programming page. So we have the x values figured out. So we have the 0, 1, 2, 3, and 4, and now we have to figure out how to get all these probabilities right here. And this is a binomial probability distribution. So luckily CAS actually already has some stuff for us in the probability tab right here. If we go to probability distributions, and if we click on binomial PDF, actually, because PDF is probability at a single point, so if we just click on that, number of trials will just do n, probability of success will just do p, and x value will just do x, for example. And I've actually already got NP defined, so it's going to take the values of NP, but we just want the general layout, I guess. So we'll just do N0, P0, just so it doesn't confuse with everything. And there we go, we get this nice expression right here. And this is basically the expression the CAS uses to calculate binomial probabilities. So if we just copy this over, copy this over, and let's just dump that into our program somewhere. Let's put it over here. Let's remove these zeros because we actually want the n and p values themselves. And let's replace this x right here with a k, because similar to what this command is doing, we're gonna take all the k values from 0 all the way up to n. So this is our expression right here, just like in the second command before. This k value right here was our expression because we just wanted a list that counted from 0 to 4, and now we want to list all the probabilities. So we know this is the expression right here. So basically all we really need to do is if we copy this whole entire line right here, because it's basically going to do the same thing, and we don't want an expression that counts all the k values. We want an expression that lists out all the probabilities. So if we just cut this right here, Control X, and get rid of this k and Control V to paste it, we have this new nice expression right here. So this is going to make a sequence, it's going to make a list, and it's going to use this expression right here using the dummy variable k, and it's going to go from 0 all the way up to n, and it's going to generate a list right there. And we have this list to matrix operation on the outside right here. That's going to turn everything into a matrix. So if we hit Control B and go back to our program, and if we run this thing right here, notice that we have two matrices now. We have the list of the x values from 0 to 4, as well as their associated probabilities. So yeah, this is basically most of the stuff done. And now it's just a matter of combining these two matrices together somehow. Notice in this table right here, I've kind of gotten in columns. So it's actually better to have these in columns right here because we're going to be using the augment command. So how can we turn these kind of vertically, I guess, turn them into column matrices? Well, to do that we just need to use the transpose. So if we kind of surround all this stuff in parentheses like so, on the outside, on the very end, if we go to the catalog and we hit the letter T, we can see this transpose right here. If we click that, that's going to add a transpose to this whole entire matrix. Remember, this whole thing inside is a matrix, and we're going to be transposing the matrix to flip it on its side, pretty much. So if we copy this over here, and Control B to save the program, and if we run the program again, notice that these matrices have been kind of flipped, I guess. They've been flipped on their side, and this is exactly what we want, because what we're going to be doing now is we're going to be combining both of these matrices side by side. So once we combine these two matrices, we're going to have 0 paired up with this value right here, 1 paired up with this value, and so on. So in order to combine these two matrices, just like this one over here, we're going to be using the augment commands. So we have these two matrices right here. So these two expressions right here are two matrices. Let's not display them anymore actually. Let's just leave them as matrices. And what we're going to be doing is we're going to be using the augment command. So augment like so. And the augment works like this. We have two inputs, one matrix and another matrix, and the augment just combines them together as long as their dimensions are the same, and in this case they are, because this sequence right here is running from 0 to n on both of these. So if we just chuck in the first one, so this is the values, the x values, we want to display these first. So if we just Control X and Control V into the first argument, and if we take this one and we chuck that into the second argument, so Control X and Control V into the second argument of the augment command, that should be it. If we press Control B, save it, and if we now run the program again, oh no, because we haven't displayed it. So this is not going to be displayed because we haven't told the program to display it. So we're going to disp this augment thing, and this augment thing is our giant matrix that we've combined. We've combined these two small matrices into a big matrix, and we're going to display it with this disp. So Control B to save it, and now if we run the program again, we get this nice matrix, and that's pretty much the same thing as we had over here. In the original one, I've had these two kinds of headers to say that this is all the X values, this is their associated probabilities. And to get this thing to display on top of this, we need to augment another matrix with the current matrix that we have. So the current matrix we have is just this matrix of these values right here, and we're going to have another matrix augmented on top in order to get this matrix right here. So in order to do this, we can't, in CAS, we can't really augment matrices together, I guess, vertically. We can only do it horizontally. So to kind of transform everything horizontally, we need to transpose this current matrix that we have, and then from there we can add on this new matrix, and then kind of untranspose everything to get everything vertically again. So what do I mean by that? So with this augment command, this is the matrix of values that we have. Let's put parentheses on the outside, and what we're going to be doing is we're going to be slapping an extra transpose on the end. So if we go to our catalog, press a T to get this transpose right here, and if we Control B to save it and run the program again, notice that this whole thing kind of gets flipped onto its side, and this is actually exactly what we want, because in doing so we can add an extra matrix at the start right here, which has these two displays, x and probability is that random variable is equal to x. So at the moment we have this right here, which is this expression right here, and let's just work on the matrix that we want to add on. So if we go to this template button right here and we just click on this column matrix, we can throw in an X, and notice that later this is going to get transposed into a horizontal matrix pretty much, and we're just making it vertical at the moment in order to kind of attach it onto our current matrix. So X, remember to put these quotations right here because we're typing in letters or a string. So X, and then we can type in the probability parentheses that capital X is equal to X, like so. And in fact, if we display this, this is what it's going to look like. So if we run the program again, yeah, we're going to have this nice display X and this probability display right here. And now it's just a matter of combining these two matrices together because we have them all ready for us. So let's just go down a few lines. So we want to now display an augmented matrix that combines this matrix and this other big matrix that we already have. So kind of going to have augments like so, and then augmenting two matrices. Our first matrix will be this matrix right here. So let's Control X and let's paste it into there. And our second matrix is this huge matrix right here. So let's copy all of that. Make sure we get everything on the ends, and Control X and Control V to paste it into the second argument of the augment commands. Let's remove these disp things right here because we don't need them anymore. And yeah, this is almost done. So this augment thing right here will combine those two matrices together. If we hit Control B to save it, and if we run the program again, yeah, notice that let's actually just choose some smaller values. So let's choose n is equal to 2 and 0.3. Yeah, notice that we pretty much have this table, but it's still kind of turned horizontally. You can keep it like this if you want to. Most textbooks actually display the table like this, but especially for larger values, as you saw before, even like 4, because of all these decimal places right here, you're going to get things hanging off the side, which you can't really see all too well unless you kind of scroll through it. So what I like to do is I like to turn it into a horizontal, not a horizontal, a vertical kind of thing, where we list all our x's downwards and all our probabilities downwards. That way it just saves more space, because we have all the space we want for our decimals right here, and yeah, it's just a bit nicer that way, I find. So in order to do that, we just need to simply chuck on a transpose at the end. So if we surround this whole entire expression in a bracket or parentheses and go to the very end for our last bracket, this is the bracket that we kind of surrounded everything with, and we go to our catalog, put our transpose in, Control B, and if we run the program again, we have this nice matrix right here that lists everything downwards. So that transpose flipped everything once again. So I'm pretty sure that is, yeah, that is pretty much it for this whole entire program. We can clean things up a little bit, get rid of all these empty lines right here, and yeah, you can hit Control B, and we can run these programs as many times as we want with anything we want to put in. So let's do n is equal to 8, and let's do 0.9 for example, and yeah, you do get these scientific notation things right here, and that's actually one of the things I forgot to do at the very start. We can kind of control how many decimal places we want to. Usually we only need 4 decimal places. So if we go to menu right here and we go to mode, we have the option of displaying digits. We can choose to do 4. So menu, what is it? Mode, display digits, float 4. That's going to ensure that we only display 4 decimal places. So if we run the program again, yeah, we get 4 decimal places, and I'm pretty sure there's an option for the scientific stuff. Yeah, I don't think there is a way to get rid of that scientific stuff. There probably is a way, but maybe I just don't know about it. But yeah, in most cases you won't have that issue right there, and you'll get normal figures like so. So yeah, that is pretty much it for this video. You can copy this for yourself if you want to, change things around to your liking, because yeah, this is yeah, pretty much a custom-made program for myself that I find is helpful for me. But yeah, that is pretty much it. Thank you guys for watching, and yeah, I'll probably be making more CAS programs in the future. But yeah, until next time, have a wonderful day, and I'll see everyone later. Bye bye.